Amichai, welcome back to the Mr. Beacon podcast.
Very pleased to be here again.
So this podcast has found its way to focus on IoT, on ambient IoT, and you really are at the heart of this emerging field. You're Wiliot's representative in standards groups, and you're very busy. I know you're spending a lot of time traveling and on calls with IEEE, with 3GPP, and there's also, a lot of interest in what we're doing in other radio standards, including Bluetooth, which obviously has the advantage of being a technology that we're using today for our own implementation of ambient IoT. But this work is about going way beyond Wiliot to harnessing the power of the enormous technology industry. Some of the biggest companies in the world who operate in, you think about the companies that operate in the world of Wi-Fi, the equipment makers in the telco industry, the network operators that have this personal relationship with almost every adult in the world. And they're the ones that potentially get bought into the ambient IoT world, that the rails of which get built on standards. And you're working on that. And of course, you've been on the podcast before. So anyone that wants to kind of get the 101 on ambient IoT standards can go back and listen to that. But I think what we should do in this discussion is do an update primarily. And, it's not like this work is done, but I think it's important. So it's very useful to have a sense of where we are at the moment. But we should also recap a little bit and explain the different standards activities, just, briefly. And then we can maybe talk about where it could go and the open questions. And the last thing to say before I hand over to you is to acknowledge, obviously, we're just one actor in a play with many parts. And in many ways, we're dancing with giants. That said, I think Wiliot has something to offer in that we have successful implementations that are being used by some of the largest companies in the world, and we're scaling to many millions of ambient IoT sensors. And so we have the benefit of learning about some things that don't work and some things that definitely do work. And so that's our contribution. But where this standards journey ends up, obviously nobody knows. But there's certainly a lot of momentum. So tell me about that momentum. And just for those people that didn't watch the first podcast, maybe you can describe each of the main standards efforts. So first of all, 3GPP, not everyone's familiar with that standards body. So perhaps you can explain who they are and what they're working on.
Yes. So 3GPP is the standard which is responsible for the cellular networks. It's the underlying technical standards that all deployments of cellular rely on. So if we have 5G, for example, we buy 5G from Verizon, the technology behind that deployment is written as a standard by the 3GPP, so that any vendor who wishes to go into market and have a play can basically read this standard and implement it. And 3GPP has been for a while. It was responsible for the 3G, the 4G, the LTE, the 5G, which was already rolled out. And now they are starting to discuss also the 6G. So usually they are not limited to the Gs. The 3GPP works on the releases which are fine resolution cadence compared to the Gs, where you have few releases between each G generation. So you can improve the features between and not just get a step response to the market.
So this Ambient IoT release will probably be many releases, I imagine. It's not going to be one and done.
Yes.
What is the name of the release and what is the name of the G, the marketing name, that this may manifest itself in?
Yes, so there are currently discussions, not clear yet, whether it is solid enough to include as a main feature or just as a study to prepare for next release. So currently we are talking about release 19, which is due 1.5 years, 2 years from now, 2.5 years from now. Release 19 is called 5G Advanced. So this is, I think, the brand name used for release 19. And I think 6G will be probably named for release 21.
Okay.
So we have, let's say, 2 releases, main releases. So it's not very hard, sometimes it gets pushed earlier if market demands or pushed later, and then releases are not fully synchronized. But this is the way 3GPP arranges its working process by releases.
So we have this standard coming to a phone near you, coming to a cellular device in your car and many other devices that surround us, courtesy of the Apples, the Samsungs, the AT&Ts, the Verizons, the Oranges. What does this, so we have our conception of Ambient IoT, which has been formed by our kind of pragmatic desire to get postage stamp size compute devices on clothing, on medicine, on all of the everyday things that so far have been offline, putting them online and unlocking the power of generative AI, ChatGPT, cloud computing, and applying it to the ordinary things that surround us. So it's in a manner turning the lights on. If we've been living our lives from a computing perspective with the lights off, with flashlights and torches, we kind of get to see things. This is a world where everything is online all of the time, continuously in real time. That's sort of, I guess, how we see Ambient IoT. How in this world of standards does this standards group see Ambient IoT? How would they define Ambient IoT?
It's a very good question, actually. Usually each company has its own vision, but I think our vision, or very similar to our vision, is what everybody also thinks about. So making it super cheap, way cheaper than order of magnitudes cheaper than what's currently considered to be cellular.
So small numbers of cents for connectivity as opposed to small hundreds of dollars for connectivity.
I won't put the number right now, but order of magnitude, few orders of magnitudes, not just one order of magnitude.
Yes.
And of course, supporting non-battery, so you can charge from air and not rely on internal battery, which is also bad for the environment, potentially be bad for the environment and limit the lifetime and require maintenance. And you are expected to have a lot of them. So all the use cases that were considered by the 3GPP are also considered. So we contributed the supply chain use case, where you are significantly reducing the waste for food supply chains and improving quality, maybe even allowing foods that were currently not possible without the tight control possible with the Ambient IoT.
So bringing visibility to the cold chain, the food supply chain.
Yes.
Currently, stuff gets harvested, put on trucks, delivered, and we only have very manual, occasional visibility of that. But this is transforming the food supply chain so that we know for every minute temperature and place of things, and so I guess we can reduce waste and have better tasting food that lasts longer.
Yes, yes.
And so I think there's a lot of benefits to whether you're selling food or eating food. That pretty much impacts every human being in the world. And this could improve that.
Significantly, I think most companies see the benefit. I mean, there were other companies that see benefit for medical. So being able to control medical supplies, medical drug administration.
So better efficacy, better, I think no one knows, literally nobody knows how much of a problem there is with people taking medicine that doesn't work because it's been kept at the wrong temperature.
Yes, and also
kept too long.
Sometimes people forget, and it can remind them, and it gets tighter control for what's the drug administration going.
Any other use cases that have been submitted that have captured people's imagination?
Yes, so there was a submission about indoor location. Currently, all indoor locations are based on Wi-Fi, which requires maintenance. You require to deploy access points which are connected to plug to electricity. Only for, being able to send a small pulse, just let you know where you are. For example, if you are in a skyscraper and someone has a medical situation which in urgency, you would like to direct the medical teams to exactly where he is, even if no one else is there to tell them we are on floor 101 or 102.
Absolutely. This is an amazing... I actually worked on this before joining Wiliot, and I got very excited about this use case. And, in America, you dial 911. Other countries, sometimes it's a different number, but you need help. But if you're in a city, it's very hard to tell where you are. And maybe you're like I'm here in Israel, and, there's a language gap. And so being able to overcome that and allowing us to get help to people that need it and knowing what floor, what building, what floor, what room.
Yes. So there is one suggestion to put stickers which don't require any batteries. They last forever, very low maintenance, very simple to anyone to deploy, and just stick them. And the phone, once it's up and you want to get where you are, you just read these the information from these tags, read out them, and then through the cloud you can really estimate where you are in the phone.
I am so glad to hear this. So this is new news to me, and this is to me a very important use case.
Yes, I agree. It's something that really solves a hard problem.
Because we feel like this should have been solved, but I think many of us who've used maps on our smartphone in a city know that there's just it's very challenging to get this right. Sometimes you can be out by a block. So, and then you think about these multi-story buildings, and there can be people who are really in serious trouble, and they can't be helped. But this could solve that problem.
Yes. I think it's a very important contribution to solving very hard problem of indoor location.
Yes.
Yes. There are, of course, additional use case for agriculture to be able to smart improve the agriculture process by tightly controlling or measuring all sorts of parameters like moisture or temperature per plant or per animal.
Yes.
If you have a pig farm or you have a very big field.
And that's important as well. If we think about climate change, whilst we speak, the whole world's facing record temperatures, and people are dying and certainly in distress. And so I think the food production is one of the biggest sources of carbon. So applying the power of the internet to reducing water consumption, reducing the inputs, healthier food, can be really interesting. And so we're starting to see, proof points and evidence of that happening, like in marijuana production, where the tagging is being driven by different regulatory needs. I think this is starting to be normalized, this idea of having Internet of Things technology at the plant level and tracing the provenance, allowing people to know where their food has come from. So one of the things that I was talking to an amazing gentleman called Professor Mike Berners-Lee, who's professor of climate science at Lancaster University. And he's has written some amazing books. I've mentioned them before on the podcast, but How Bad's a Banana? The Carbon Footprint of Everything is one. And then There Is No Planet B is another. And he, one of the things that I think he has expressed some optimism about is the power of mobilizing our wallets to spend money on food that actually regenerates the planet rather than makes the planet worse. And there are farms where the carbon's going into the soil and it's not coming out. And if we knew those farms and could say, I want to buy food from regenerative farms, that could be huge. Why would we do that? To save the planet, but also because it tastes better, has less artificial fertilizers and pesticides. And I think our ability to use ambient IoT to join up people that make things with the people that consume things is tremendously powerful and just makes for a better experience. I go to one of my favorite stores in San Diego. It's called Jimbo's, and they have a little sign that says, this came from this farm that is like 33 miles from this store. This could scale. And if everyone knew that, then we can really make a difference as individuals and also get better food as well. So that's great that that's in there. I'm really pleased. So just to recap, we've been going through some of the use cases, and this is the way the standards process works, right? You don't just come up with technology and look for a solution. You say, here are the use cases. So we could go on, and I know there are other use cases, but these use cases, again, not just coming from Wiliot, but from companies like Apple and, Find My everything. So tell us a bit about the mechanics of creating that standard and where we are in that process.
So we started with the initial use cases, and now we are starting to see how the existing deployments, devices can support this technology. What is required for them in order to support it in the economic way, beneficial way, timing way, best time to market. And so it's kind of like you need to now connect between the dots. It's a very hard job of you have requirements on one end and the device on the other end. And you need to see what is the shortest way between these requirements. It's very appealing to say, okay, let's rebuild everything from scratch. But this is not an economical or sustainable solution. So you want to be able to connect them in the most efficient way, which also makes sense for all vendors, so the ecosystem can grow. We start, of course, with the basic, only the link layer. What connections do we want? Do we want to connect directly to the base station? Do we want to connect to a small base stations called picocell? Do we want to connect to the phone? Do we want any relay in the middle to be able to assist us? Do we want a specific band? So cellular currently has a lot of channels. Verizon has specific
different
channels.
Frequencies.
Yes, different frequencies, yes. And then which channel do we want to use? There are a lot of questions. What is the security? How to apply the security? How do we manage so many devices? So you have foreseen thousands of devices and management of such a big number is not very simple task in terms of the network.
Sure. I mean, so at the moment, there's roughly 1 billion phones made every year, but we're talking about orders of magnitude, maybe even 3 orders of magnitude more devices. So not billions, but the internet of trillions of things. And fortunately, this industry is very good at dealing with scale. That's one of the things that they bring, I think, beyond just the technology. It's a set of companies where there are customer service and portals. And so I'm excited about the telco industry joining Ambient IoT because there's a level of governance and trusted companies. We may not love them, but we trust them. We're familiar with them that can help bring order to this. So that's a really good thing.
I think there are a lot of engineering efforts, IQ efforts from these big companies that, can really improve and get a very good working devices.
So I interrupted you. So just so there's, you have numbers of, I find this fascinating. How do you get something as complex as this to be agreed by so many companies with vested, sometimes conflicting interests and just opinions on the right way to do it? How is that organized?
So I think every company has its own set of wishes, own set of customers, and all sets of engineering skills. And then each company has its own trade-off, internal trade-off, what should we focus, what should we defocus. And then we have negotiations between the companies. Each company wants something else. And company gives a list. So every company gives this list. We have the operators, for example, who are the customers eventually. They have what they want. And they put Ambient IoT there, quite high in their wish list. And then the technology companies say, we can deliver it for the next year or not. Or we want to delay it to later release. And then we have a lot of discussions. What will be the features going in eventually? What is easiest? And this is usually done it's a process in a meeting called workshop. So during the workshop, all the companies come, flash their feathers, and then eventually you come up with what most of the company thinks it's reasonable, agreeing to this, and then start the actual work of the converged task.
So we have a list of dozens and dozens of features that could be in release 19, what will become 5G advanced. Maybe we don't give specific numbers, but roughly how many features can be fit in a release, and roughly where is Ambient IoT? Is it the top, at the bottom, below the bottom of the cut line? Where are we?
So I think it's a good question. The Ambient IoT is very high on the wish list of most of the companies.
Yeah, which makes sense, because whether you're an equipment maker or an operator, there's huge value. There's a lot of money to be made, as well as solving, we all want to be found if we're having a stroke, or we all want to have good food. We all want to have the climate problem solved. So hopefully that weighs it.
I think also it's if you want to prepare to 6G, you must start with a certain feature early on.
Yes.
In order for them to mature towards the 6G, you cannot wait too much. So this is a trade-off, actually. How many features you want to keep on working from 5G, and how many new features towards the 6G you want to start including.
Okay.
There is a trade-off. Of course, there is no single answer. The fear for Ambient is that it's too much work. So whether it can fit in or not, this is the main concern. There are a lot of other items, of course, other technology, other features. For example, connecting a phone to a non-terrestrial network. Satellites, yes. So you get coverage also once you are outside of a big city. There are many other features. Some are very small, require a very modest amount of work. Some are bigger. So this is the discussions going on.
Okay.
And eventually what will come up, it highly depends on eventually the converged focus of the company. So if the focus is on very sophisticated or high end, it may take longer to develop, and then they might consider just, okay, let's keep on studying it, making sure we can actually deliver it in 1 year, because it's a lot of work, a lot of engineering working on that. So we need to make sure we are not targeting something which will be too much for the time scale that are currently defined.
So it sounds like there's some enthusiasm for it, but there's still some final decisions to be made as to whether it can be fit into release 19 or not.
Correct. As a feature.
As a feature.
As a study item, so we are going to work on it. There is no question. I think this is almost... so you can never know, of course, until the decision is made. But from what I noticed, other companies are excited about it, want to know more about it. It kind of... both the engineering and the business is excited about it. They need to understand the work impact to make sure it fits into the release 19 timescale. So this, I think, is the main
very good
discussions, yes.
Well, we could talk more, but there's other standards work going on in other bodies. So when you're not on a plane or a conference call with our colleagues in 3GPP, you're also working with IEEE that defines Wi-Fi. What's happening there?
Yes, IEEE is the standard body that defines the Ethernet, 802.11, and also the Wi-Fi, Ethernet over wireless.
Mm-hmm.
Yes. So in the Wi-Fi a task group was, not a task group, but interest group was formed last year, just to understand if it's possible, if there is a possibility to connect to standard Wi-Fi network, our ambient tags. And a lot of work was done there, a lot of researches, a lot of studies done by several companies. And the results, it seems reasonable. And so in the IEEE, the process is in order to become a task group, which task group needs to finish the task of defining the ambient, the standard underlying ambient tags. We first need to define the project. So the study group was formed in order to define a project where all companies agree what will be and what won't be in the project. For example, we discuss what frequencies should we include. We have, usually Wi-Fi has a lot of frequency. It can work on 5 gigahertz. It can work on 2.4 gigahertz. And it can also work on sub 1 gigahertz.
Oh.
Yes. So
2.4 is kind of where it all started, very busy. It's also shared with Bluetooth as well. So
yes.
That's interesting. So any view as to what the frequencies are that will be used?
So currently we are discussing to be focused on 2.4 and also on sub 1G. Two bands that are currently being discussed to be the targets of ambient tags. 2.4 is very appealing because you get very harmonized across the world single band.
So it doesn't matter what country you're in, 2.4 gigahertz is available. No one's going to get into trouble for stamping on a frequency that's being used by the emergency services or the armed forces. So it's available.
Globally available.
And so what's good about, so why not just use 2.4? What would we use that lower sub-gigahertz frequency for?
So 2.4 is very appealing. It's also all the other devices, the older devices, the legacy work on that. So you can get practically received everywhere. There are issues with this band. First of all, it's very crowded.
Mm-hmm.
You have a lot of devices there. So there are concerns to avoid too much radiating too much to this band, to avoid the interference. And the other thing is that sub 1G conducts power much better compared to 2.4. So if we are to conduct power and charge our tags can be can work much better if it is working on the sub 1 gigahertz band compared to 2.4. Still, they are both working well. This is better. So
this makes sense. And I guess we have practical experience. We have a product that's scaling to more than 100 million units, and it pretty much uses those bands today. The 2.4 for sending data and the sub-gigahertz for harvesting power. And I think we're all concerned and want to manage how busy that 2.4 is, because it is used by current Wi-Fi devices and Bluetooth devices. But I have some personal experience. I sit in our offices in San Diego. I have something called the wall of Wiliot behind me, which is 1,000 Bluetooth tags, all being energized, all broadcasting. And I'm able to use my earbuds, my wireless mouse, my wireless keyboard, and it works fine, because these devices are it's not like streaming music. It's little bursts of data. So, and of course, 2.4 isn't just 2.4, it's actually many channels, isn't it? So that'll be very interesting to see if we can work on some good schemes to use the dozens of different channels to send that data and make it really scale.
Perhaps you can join the actual meeting, because this was actually one of the main discussion points in the last meeting.
Well, conference me in next time, and I can point to 1,000 tags behind me.
So people are very, well, you say you have hundreds of tags. How can we work together? It's too much. But your point is really right, because every tag sends only like very tiny amount of bits, very infrequent.
Yeah.
And very low power, every tag.
That is the key. We're whispering. The analogy I use is like, because when we first brought our product out, people were saying, what's the range? What's the range? You need to have long range. And we have very short range. If our tags are talking, and they do kind of talk, they're really whispering. And so it's like having a big restaurant. If everyone's shouting, you can't hear everyone. But if every table's whispering to each other, you can have a lot of tables and they can get a lot of great discussions going. And so having tags that whisper is really the source of scalability. And then maybe something great comes out of a discussion at the table and someone stands up and then they shout out, oh, this is what we've decided. And that can then go out to, a broader set of people. And that, in a way, is the way we're organizing our product, with tags that talk to these bridge devices that consolidate and then occasionally shout out the answer to the wider network. So I hope that's the way things go, because we want it to work, and that's what we've seen does work.
I think eventually the technical and the physical world kind of leads you to very similar solutions. There is no
pragmatism
magic
rules.
Here. Yes. So I think it's not coincidence that our product is 2.4 and sub 1 gigahertz, and the Wi-Fi is also discussing these bands. This is the bands that make sense. And of course the other problems also. I think we face. Maybe Wi-Fi will find different solutions than what we did. Then that's also very good.
Yes.
We have multiple of solutions, But to understand, the important thing, I think, is to understand the problems, which is very different than cell phone or hair dub. It's different. It's different type of traffic, a different type of security, different type of range, as you said. So once we understand really understand the problem, then we can find the solutions.
So how have things progressed? So it sounds like there's some good discussions going. How far have you got in the standards making process with IEEE?
So in the IEEE, I think the group for ambient power, all the companies that are involved directly, I think we kind of did manage to get some sort of agreement, but we still don't. We need to align with other groups and other companies as well, in order to make sure the project is aligned and fits well in the entire .11 ecosystem. So this is the stage we are at now. I think we need to convey the AMP, the differences, all the things we talk here about, the differences between what's AMP to regular Wi-Fi, so that it's more clear to other groups as well, not just to the working group that focus on this issue. So I hope in the next few months we get this done, and then we can start, I hope by January, even before, the task group. Task group stage, we are starting actual work on what are we going to do, what we define, how we define it, what is how the bits are going through there, how the energizing is going to happen, what is the signaling needed, security, the routing, all the technical details that needs to be filled in order for the device to work well.
That's good. So we touched on this in our previous conversation, but I want to revisit it. We have IEEE, we have 3GPP, we have Bluetooth that already has implementations on it. Is there room for these three standards? How do they compare? Will there be a winner? Will there be a loser? How would you differentiate between what's likely to come out of those three different standards bodies?
Yeah, first of all, I think we are defining a new device type, a new class. So it's important to remember we are not just adding a feature to our phone. We are defining a new class of devices. And in order for such a class to be successful, we must have a variety, because not every market has the same requirements. So I believe that these standards each will have its own niche of the same class of devices. So, for example, the cellular usually defined license band operations. So it's more expensive usually compared to Wi-Fi. However, it gives you better performance, better reliability. So you get better service with higher cost. So you get a variety, which is very, very important for ecosystem. For example, maybe you want to have coverage in hard places, and you are willing to pay more for the data going from hard places, compared to data that is easy places, let's say, with easier to get the data, and then you are willing to pay less, and you're getting a different devices, a different service.
I guess you have quality of service with the cellular license band, but you also have customer service, don't you? You can actually go onto a portal and talk to someone about the coverage in this area. And I think especially as we start to think about privacy and normal people making sense of this ambient IoT world, where everything in their pantry is online, and everything in their medicine cabinet, in their drinks cabinet, in their tool cabinet is online. And maybe not everyone wants that. For me, I want to know whether my kids have remembered to take their medication, whether my parent has taken their medication, whether it's been kept at the right temperature. I don't want to run out of Bombay Sapphire gin. I'd like to have that auto-replenished. But quite legitimately, some people might not want to opt into that, and they want to talk to someone about making sure that no one's observing their drinking habits or knowing the medicine they're taking. There's pros and cons to all these things. And the thing that I like about, yes, maybe you pay a little bit more for the telco grade service, but you have someone to help with the governance and the customer service. So I think there's a lot to be said for that. But free is also good. So,
I think we need both. I mean, there is no one winner takes it all, like Abba said. It's like you have a lot of markets with a lot of needs, each with its own unique. Even the same customers sometimes have different problems they need to solve. I guess controlling the field is not like controlling in store, different places. So I think it's a very healthy process that both have the development and the types, and that in the early stage, we can see the differentiation between and understand the differences, the commonalities and the differences. And I think it also appeals to more companies. Once you have more standards, each has its own unique IP handling and technology investment portfolios. So, and every company has a different view and different angle on that. So it allows more company to get in. So if it's example, only cellular did it, much fewer companies would have implemented it compared to if also Wi-Fi is defining it.
Yeah, that is one of the things that excites me about this. I mean, Internet of Things is not a new idea. It's been around for decades, but I don't think it's really achieved its full potential. And one of the things that can help change that is some of the giants that operate, that have this recurring revenue relationship with almost every adult, almost every adolescent in the modern world. And I think it's going to take those giants to bring the innovation and the ecosystem of applications writers that are going to sit on top of these ambient IoT platforms and really harness the creativity and make it easy to use and scale. And standards are the basis of all of that. Without this, it's like laws. Why is America, for all its faults, such a great country for innovation and commerce? It's because they have basically pretty solid legal system and standards, and that's really what we need to bring to IoT. So Amichai, we normally do the 3 favorite songs. You've been on the show before, so we've already done that. So I wanted to instead ask you about something a little unusual. You, as well as leading our standards effort, you are also another kind of leader of filmmaking. What? Tell us a bit about this movie that you made, and what was your role in it?
It is kind of like a passion of mine. I really liked movie all the time, so I wanted to create one. So I studied a little bit directing, where directing is like you need to know everything. So you study a little bit acting, a little bit camera, a little bit production, a little bit screenwriting, or you know a little bit about anything. And then you need to compile everything into one creation.
It's holistic.
Yes.
Which I think good standards should be holistic, shouldn't they? They have to balance many things.
There are a lot of commonalities with the actual work, actual doing things. So even though, of course, movies are more creative and much more flexibility to do a lot of things, but you still have legacy also in movies, similar to the standards, and you still need to move people to the right direction, very similar to the standard work.
Yes, you're harnessing a lot of different creative ideas. Sometimes
Right.
there's conflict.
All the time there are conflicts.
Yeah.
Of course, yes. And you need to lead and have a vision of the clear vision of what you want it to be. And get everyone on board with their own creativity and knowledge and expertise into one coherent creation. And the standards is very similar in that sense.
Yeah, and you need to be flexible, don't you? You need to adapt your style, behave differently with different people, understand what they need in order to get the best.
Yes.
But ultimately, you have a responsibility to the work for making sure that it all comes together. That has to be the primary driver. So what is the movie that you made?
So I made a movie about a group of engineers who worked on during the time of the Second World War. It's a historic movie with a lot of props and artifacts and art, a lot of art related to the time, to the historic time, and basically I will not reveal the entire plot.
No. But what was the engineering task they were working on?
This is part of the. It's a hard movie. It's not a comedy or.
Right.
It's a drama. It's a
drama.
A drama, exactly, where you kind of take engineering, which is surprisingly not very different from what it was like 50 years ago. I mean, solving engineering, a group of engineers needs to solve engineering problems, behave very similar, act very similar. Even though today we have computers, the essence is very similar. And then I am showing a specific problem they faced, and using all the historic context. And I hope it relates anyone who is currently working in some high-tech or engineering company to what it was like 15 years ago. You can actually relate and understand that things are not very different eventually.
So this is, it's funny how there's these waves of creative productions, like Oppenheimer's just come out as we're recording this. So it's in the States, it's a big movie. So maybe there's some parallels, maybe obviously a different engineering task, I imagine. So what is the movie called, and is there a way that we can see it? I haven't seen it. I'd like to see it. So
it's The Engineers, it's called, and
The Engineers. Okay.
Engineers. And I'm going to send it to some known festivals.
Uh-huh.
Let's see if I get in.
Yeah.
Some marketing and publicity in order to get, and only then I can publish it to public networks like, Vimeo and things like that you can actually see the movie outside. Currently, there is no way to see it.
All right. And is it in Hebrew?
It's in Hebrew, yeah.
And so subtitled, hopefully, for those of us who are slightly less fluent in the language.
Yes. When you are doing it in Israel, it's not very easy to find English-speaking actors. So I had to do it in Hebrew, and I will add some subtitles in English as well.
Excellent. So I think you're doing very important work. Thank you very much for what you're doing. I know it's at some personal cost with the late hours and all of the travel, but appreciate your updating us. And I will check in again and see how things are progressing. Thank you, Amichai.
Thank you very much for having me. I hope to see you again.
Thanks for watching this episode of the Mr. Beacon Ambient IoT podcast here on YouTube. You can listen to this episode on iTunes, Spotify, or wherever you get your podcasts. If you enjoyed it, please like and share this video. And be sure to subscribe for more videos. For more information about Wiliot, Ambient IoT, and IoT Pixels, head over to wiliot.com.